Hi, my name is Clay, and my project is the design and evaluation of an FPGA-based interconnect for more efficient data center use. So, AI data centers are becoming an increasing concern because of rising electricity and resource demand. However, a large contributor to this footprint is the excess capacity that is kept online within these data centers to absorb the rare but severe traffic spikes. During these high to latency periods, the bottleneck is rarely the servers themselves, but the queuing switch within the servers that direct the traffic between them. And so my project aims to create a more efficient data center switch that is able to decrease the tail latency, therefore decreasing the amount of extra capacity that is needed for these data centers, decreasing the amount of extra resources it uses. So in order to test and optimize a data switch, I had to first create a test board. I created a PCB test board and used RP2040 dev boards as server nodes. I used UART and SPI to direct traffic to the FPGA switch. Then I implemented a bunch of typical algorithms within the FPGA switch to just have a point of comparison. I implemented round robin, deficit round robin, oldest packet first, and my custom Atlas, which stands for Adaptive Tail-Latency-Aware Scheduler algorithm. Atlas uses a bunch of different factors, but it also takes into account the current utilization of the server and also how much traffic is coming in, along with the amount of time that the packet had waited. And so by doing this, I was able to get an 84% decrease in tail latency compared to the baseline with Atlas, which would be the equivalent of an 84% decrease in extra capacity needed for these data centers. Now, even a small reduction in the energy uses of these data centers can be the same as millions of US households worth of electricity. So this decrease is a large contribution and could be the equivalent of millions of US households worth of electricity.